Okay, welcome to Moigame YouTube. This is physics for natural science or freshman students. This tutorial is for general physics that prepared for natural science student or freshman student. And the reference for this PPT or this lecture is directly prepared from the material that prepared by Ministry of Education of Ethiopia. So it is today we will see the introduction part, some concept on general physics. So this chapter 1 is about the preliminaries of physics. We know physics is the basic science and have many applications for the easy of the life. In our today years or this 21st century, many complex problems are solved on the transportations, on energy, and many more science. So those science are application of basic science. From this basic science is physics is one. So the application of physics are very wide. Uh, so physics deals with matter in relation to energy and the accurate measurement of natural phenomena. So in our world today, energy generation or power generation is one application of the physics. And the measurement of natural phenomena is also the application of physics. So physics in general, as a natural science, it deals with matter in relation to energy and the accurate measurement of natural phenomena. When we say measurement, measurement consists of the comparison of unknown quantity with known fixed quantity. Always when we measure unknown quantity, we measure with fixed quantity. This fixed quantity has known, should be known. So in the measurement, it consists of the comparison of unknown quantity with known fixed quantity. Physical quantities and measurement. Physical quantities and the measurement. When we say physical quantity is quantifiable or measurable assignable property ascribed to a particular phenomena or body is known as physical quantity. For instance, the length of the rod or the mass of a body are physical quantity because we can measure the length of the rod against the mass of the body, so it is quantifiable. So if the property of a given matter is measurable, then we can say physical quantity. Again, measurement is the act of comparing physical quantity with certain standard. So during measurement, there is a comparison of physical quantity with certain standard is known as measurement. We can categorize physical quantity into two. One is basic physical quantity and another is derived physical quantity. When we say basic physical quantity, what do you mean? Basic physical quantities are quantities which cannot be expressed in terms of any other physical quantity. So it is known as basic. Basic physical quantity kan nuyi jennu yoo quantitiin sun termii other physical quantity dhaan yoo hin ibsamu ta'e maal jenna basic physical quantity jenna. For example, length, mass and times are basic physical quantity because we cannot express length, mass and time in other physical quantity. So length, mass and times are basic physical quantity. Not only length, mass and time, there are 7 fundamental or basic quantity we will see in the next slide. And other units or other physical quantities are derived except those 7 quantity. Derived quantity are quantities that can be expressed in terms of fundamental quantity. The derived quantity can be expressed in terms of fundamental quantity. For example, area, volume, density. Those area, volume, and density can be expressed in other fundamental quantity. For example, if you consider the area of rectangle, let's say this is a rectangle with length L and height h. So if the length of this rectangle is L and height h, so area of this rectangle is equals to length L times height h. So these L and h's are fundamental physical quantity. This is their length and h are the fundamental physical quantity. So L times h is area. So area is derived from other physical quantity, other basic physical quantity. So area is derived quantity, length and h's are basic or fundamental quantity because area can be expressed in terms of other fundamental or basic physical quantity, but length and h's are not expressed more in other physical quantity. For example, volume of the cube. This is a volume of cube. If this is a cube and with length h and depth h, this is L, h or width and h. So volume is equals to L times W width times h. LWH. So L is unit of length. It is a length, not unit. It is a length. W is a length. H is a length. All these three are lengths. So volume is derived from the length. This length is fundamental physical quantity. Another is density. If you take density equals to mass over volume. Mass over volume. And its unit is equals to kilogram per meter cube. Kilogram per meter cube. If this is meter cube, so this kilogram unit is unit of mass. Mass is basic physical quantity. M is meter. It is unit of length. Length is basic physical quantity. So density, volume, and area are derived physical quantity, whereas length, mass, and times are basic physical quantity. So the difference between derived physical quantity and the basic physical quantities are basic physical quantities are quantity which cannot be expressed in terms of other physical quantity, but derived physical quantity can be expressed in terms of other physical quantity. These are the major difference between basic physical quantity and derived physical quantity. As I have said, there are 7 basic quantities are there. Those are length, mass, time, temperature, electric current, amount of substance, and luminous intensity. All those are basic quantity. Their symbols, the for length L, for mass M, for time small t, for temperature capital T, for electric current capital I, amount of substance N, and the luminous intensity F. Its corresponds unit for length meter, kilogram for mass, second for time, Kelvin for temperature, ampere for electric current, mole for amount of substance, and the candela for luminous intensity. So all these are basic quantity. Another derived, there are many derived quantities out there. Among these, force, speed, pressure, energy, power, all these are derived quantity. For example, if you consider power, pressure is equals to force over area, force over area. So this force is derived physical quantity. Again, area is derived physical quantity. Force means force is equals to mass times acceleration, ma, mass times acceleration. Acceleration is equals to change in v or change in v over delta t, or velocity over t is acceleration. Again, v is equals to velocity equals to displacement over time, when this is a displacement or position. So substituting this value, pressure is equals to force means acceleration, mass times acceleration, mass times acceleration. Acceleration means change in v. Change in v means change in s. Change in s or displacement over time is velocity over time. Yes, delta s over t is v. V over t is equals to acceleration. So here mass is basic unit, basic physical unit, Displace S is also basic physical unit. So pressure equals to P equals to mass times delta S over T square. Time square is the unit of what? Pascal. Sorry, over area. Over area. Area means over area. So over L square. For example, for rectangle over area. Area means is equals to L. So this is delta S basic, delta T basic, mass is basic, area is length basic. So all others derived quantities are derived from basic quantity. Vector composite and resolution. What's the difference between vector and scalar? Vector is scalar is a quantity that is completely specified by a number and a unit. Only a number, and if the quantities are only specified by a number and a unit, we can say scalar. For example, if we say speed of a given car is equals to 2 meters per second. 2 meters per second. So 2 meters per second. So this is scalar quantity because it is only specified by number 2 and unit meter per second. Here there is no direction. So it has magnitude but no direction. Magnitude is equals to 2 meters per second but no direction. So such a type of physical quantity is known as scalar quantity. For example, mass, time, volume, speed. So you can add this, a rule of ordinary algebra. For example, if this container has 2 kilograms of orange, orange, 2 kilograms of orange, and 5 kilograms of banana, then banana. So the total mass inside of this container is equals to 2 kilogram plus 5 kg, 5 kg. So this is equals to 7 kg. So algebraically you can add 7 kg. So this is, you can add ordinary algebra. Another type is a vector. Is a quantity that is specified by both magnitude and the direction in space. If it is specified both magnitude and the direction in space, we can say vector quantity. For example, velocity of a car equals to 5 meters per second north to the north to the north. So this is both magnitude and the direction. It is expressed by magnitude and the direction. 5 meters per second in what direction? North direction. This is velocity. So displacement, velocity, acceleration, and the momentums are best examples of vector quantity. Vector quantity. Vector representation. Always vector is represented by an arrowhead. Vector is represented by arrowhead. For example, if you write acceleration, acceleration a vector quantity, so arrowhead, this is acceleration. Force, force is vector. Velocity is a vector, so an arrowhead. So this arrow indicate vector that physical quantities has, or that physical quantities are vector quantity. Vector quantity. Vector addition. Uh, A single vector that is obtained by adding two or more vectors is called a resultant vector. Only we have one resultant vector. So a single vector that is obtained by adding two or more vectors is called a resultant vector. So adding two or more vectors give only one resultant vector, not two resultant vectors. So the summation of two vectors give one resultant vector. For example, graphical method of vector addition. Graphically how to add the vector. So graphically vector can be added by joining their head to tail, head to tail, head HT, head to tail. For example, here the head of the first vector connecting the tail of the first vector to the head of the last vector. Then the vector that we get from this is resultant vector. So for example, it's vector A, vector B, and the vector C. If all vector A, B, C's are connected, then the resultant vector is equal to the summation or the connection between tail of vector A and the head of vector C. So this is a tail, this is head of vector A. This is tail of vector B, and this is head of vector B. This is tail of vector C and head of vector C. So according to the graphical method of vector addition, connecting connecting tail of the first vector means vector A is the first vector, this one, and the head of the last vector, head of last vector is this one. So the connection between these 2 points is give us resultant vector. So resultant is the summation of vectors, vector A plus vector B, vector A plus vector B plus vector C is called resultant vector R. Another point is parallelogram law of vector addition. In parallelogram law, the resultant of two vectors A and B is equal to the diagonal of the parallelogram for which the two vectors A and B become adjacent side. So in parallelogram, the resultant of two vectors A and B is the diagonal of the parallelogram for which the two vectors A and B become adjacent. So adjacent side for two vectors is A and B. So resultant is equal to this one. All three vectors A and B are concurrent, also called component of R. So the magnitude diagonal or resultant vector is obtained using cosine and law and the direction, and using the side law. So cosine law is equals to resultant array is equals to a square plus b square minus 2y of the angle between these two vectors, AB cosine theta, AB cosine theta. So this is equals to the resultant R. Side law means always sine is equals to sine theta over the opposite line. So sine theta opposite line for angle theta is the resultant R. So sine theta over R equals to sine alpha opposite angle is equals to opposite line is equals to A, which is equals to sine of beta, the opposite line for angle beta is B. So sine theta over RR equals to sine alpha over A equals to sine beta over B. This is the application and calculating resultant for using the sine and the cosine law. Sine law is to get the direction, cosine law is to get the resultant. Another point is component of vector, resolution of the vector, how we resolve the vector component. So component of vector given vector are obtained by applying the trigonometric function of sine and cosine. Sine and cosine. Here, one point you have to remember on this component. First, we have to identify the location of the angle. Next, the adjacent line, resultant line. So, if theta is located along or in the positive x-axis or in the first quadrant, so resultant or cosine theta, so this is adjacent line, AX is adjacent line, AY is opposite line because it is opposite to the angle theta and it is located at the opposite side of angle theta. So AY is opposite line, AX is adjacent line for angle theta, and A is resultant. So cos theta is always equals to cos theta is equals to cos theta is equals to uh, adjacent line over hypotenuse. So adjacent line for cos theta is equals to ax. ax is the adjacent line over hypotenuse equals to a. Hypotenuse is equals to a. So cos theta equals to ax over a. So from this ax is equals to ax equals to multiplying a times hypotenuse. So a times cos theta is equals to a times cosine theta. Cos theta is equals to what? The adjacent line ax. Again, theta is cos inverse of ax over a. Cos inverse of ax over a. Another point is, if for example, what happens if theta is located here? Let's say if this is a beta. So for beta, what is the adjacent line is ay, and the opposite line is ax. Hypotenuse remain unchanged. So cosine of beta, cos beta equals to adjacent line. Adjacent line for angle beta is not ax, ay. Ay over hypotenuse line is equals to a. So for cos beta equals to ay over a, not ax over a. This formula is not a constant. So this formula is not a constant. Or this formula is not a constant. It is depend on the location of the theta or angles. We find or calculate the cosine theta, sine theta depending on the location of the theta. For example, for theta, adjacent line is ax. For beta, adjacent line is ay. For theta, opposite line is ay. For beta, opposite line is ax. But both of them angles have the same hypotenuse a. So don't forget to consider the location of the angles. A unit vector is a vector that has magnitude of 1 and it is dimensionless, and it is sole purpose to point a given vector in a specific direction. There are a special set of 3 unit vectors that exceptionally used for problems involving numbers. So unit vectors has magnitude 1. Again, it is dimensionless, no dimensions. There are 3 unit vectors are there. These unit vectors are I unit vector in the x direction, j unit vector in y direction, and the k unit vector in z direction. So the magnitude of these unit vectors are 1. So for Cartesian coordinates, there are 3 unit vectors I, j, k. For 2 dimension, we have I and j unit vector. So these indicate I is indicate in the direction of positive x, j is in the direction of positive y, and the k is in the direction of positive k. Vector addition and the unit vector notations. In vector addition, only we add the same unit vector together. For example, let vector A is given ax in the I, ay in j, and az in k. Let beta vector is given by bx in the I, by in j direction, bz in k direction. So adding vector A and B means adding like term or like unit vector. ax plus bx in the I direction, ay by in j direction, plus az plus bz in k direction. So the sum of vectors that expressed in unit vector notation is simply the sum of x component times I plus sum of y component times j plus sum of z component times k. So this is a vector addition in the notations. Another point is finding a unit vector. Finding a unit vector. Let's consider this is a vector R given by x in the I, y, j in the z, k with respectively x, y, z coordinates. The unit vector are in the same direction as the vector are simply the vector are divided by the magnitude r. So r here is equals to unit vector r is equals to r unit vector over this magnitude means x, y, j, z, k over r. So x over r in the I direction plus y over j, r in j direction, z over r in k direction. This is the value of the unit vector. So the resultant makes clear that each component of unit vector is simply the corresponding component of the original vector divided by its magnitude, where r is equals to the summation of the square of each component, means x square, y square, z square, and the radical gives their r, the resultant r. So each unit vector divided by r gives the magnitude of unit vector. Let's say on these given review problems, let's do some problem. Let's do vector question number 3. Question number 3 states that if vector A is C is find A B such that here solution for question number C, let vector A equals to value given A times vector A times A plus B times B caps plus C equals to 0 for question number 3. Question number 3. So here vector A equals to 6i minus 6j. 6i. So if you multiply this vector A, so A like term A times 6 in the I direction, plus or minus B times 8 in the I direction, C plus 20 C times 26 in I direction is equals to 0. This is equation 1. Equation 1. And for equation 2, A times minus 8 not minus 8, yeah, minus 8 plus 3 plus 3 A plus C, where is C plus 90 equals to 0. So solving this line, this equation, 6 minus 8b
plus C26, and then finally you get the answer.
So A times A plus B times B plus C 0. A in 6 minus B in 8 in the I direction plus C 26 here. Second equation, minus 8 plus 3A plus 90 is equals to 0. So you should have to solve this equation.